So today we are going to do the last question of exercise 13.3. The question is, a farmer connects a pipe of internal diameter 20 centimeters from a canal into a cylindrical tank in her field. So this diameter is given 20 centimeters. Okay. Suppose this diameter of the pipe is given 20 centimeters. Just see, it is given in centimeters. Okay. And cylindrical tank which is 10 meter in diameter. So this diameter of the tank is D, suppose, and this is in 10 meters. It is given in meters and 2 meter deep. So this is very small as compared to diameter, but in figure it is for your understanding. We have taken long height of the cylindrical tank. Now the water is flowing. This water is flowing inside this tank. The water is flowing inside this canal. This water is flowing and she is filling the tank. And the water is flowing at the rate of 3 kilometers per hour. That means, because everything is given in meters, so we can say 3000 meters per hour. So how much time it will take to fill the tank? Now the water is flowing at the rate of 3000 meters per hour. So we don't know this length actually. How much length is this pipe is having? So let us suppose that this length is x. Okay, this length is suppose x from here to here. This is x length. Okay, so this length is supposed to be x, means in x meters. In x meters, how much water will flow? In x hours. In x hours, this is not length. You take x 3000 meter in 1 hour. So in x hours, how much meters will it flow? So this is, you take x hours, not the length. We will take in x hours how much it will flow. So, or we will take that, suppose in x hours the tank will be filled. Let the time to fill the tank be x hours. Okay. So in x hours, how much this will flow? How much will be the length of this flowing in x hours? So as you know that in 1 hour, it is flowing up to 3000 meters. So how much it will flow in x hours? Suppose in x hours, it will flow 3000 x. So this 3000 x will be the length of this flowing. So from here, it is 3000. This length is 3000 from this point to this point. This will be, suppose in x hours, it will flow 3000 x meters. 3000 x meters. Okay, because we need to compare their volume. So 3000 x meters, suppose it will flow for filling the tank. So whatever water will be flown in 3000 x in x hours, that volume will be equal to the volume of this cylinder, because we suppose that in x hours it is filling up to the brim. So volume of water flown in canal in x hours will be equal to the volume of cylindrical tank. Volume of cylindrical tank. Here we are taking capital D, so radius will be equal to capital R. So capital R will be equal to 5 meter. And here H height is capital H. So here will be small h. And this diameter will be equal to 10 centimeter, but it should be converted into meter because everything is given in meter. So 10 divided by 100, so 0.1 meter, 0.1 meter is the radius of this canal. So volume of this is also a cylinder, this is also a cylinder. So pi r square h will be equal to pi capital R square capital H. Compare to get the value of x. This pi and pi can be cancelled, and r square is 0.1 into 0.1. H is 3000 x. H is 3000 x. And right hand side radius is 5 into 5 into height 2. So this will give you the answer in hours. Later on we will convert into minutes. 5 into 5 into 2 divided by 3000 into 0.1 into 0.1. So just you have to 5 into 5 to the 10 or 50 you can write, and this is decimals. Remove the decimals from the denominator, 2 decimals. There are 2 places after decimal, 2 zeros will come, and this will be 3000. So 5 by 3 hours. Okay, now convert into minute. 5 by 3 hours. 5 by 3 hours. 1 hour means 60 minutes. So multiply by 60. So 5 by 3 into 60 minutes. How much time it will take? 5 by 3 into 60 minutes. So 3 ones are 3, 3 twos are 6, 5 twos are 10, 100 minutes. So it will take 100 minutes. The water flows through the pipe at the rate of 3 kilometers per hour. Then it will fill the tank in 100 minutes. So therefore, it will fill the tank in 100 minutes. Frustum of a cone. This is our deleted portion this year. So just we should know about it. So it is our deleted portion. This is deleted this year. But we are going to do some formulas and you can do simple type of questions. So when we cut this plane, when we cut this cone by a plane which is perpendicular to this axis of the cone, so it will divide into two parts. This, the part below it, this is called the frustum. This part in the form of bucket is called frustum of a cone. So obviously it will have two radii. This is the above one radius, this radius, and this radius. So better to take small r and capital R. And it will have a height. This will be its height h, and this will be its slant height. So what will be the volume of the frustum of a cone? So volume of a frustum of a cone. Frustum of a cone is equal to 1/3 pi h r square plus small r square plus r, capital R into small r. This is the formula of frustum of a cone. If two radii are given, then we can find the volume of the frustum by using this formula. And curved surface area of the frustum, curved surface area of a frustum of a cone. So generally it is having the shape of buckets. So question they are asking, a bucket is having two radii, this and this, its height is this, find its volume. So its curved surface area will be equal to pi, that is pi RL. Here you have to take r plus r, pi r plus r into slant height L. Okay. Next, total surface area. Then what is the relation between L, R and H? So L, R, there is a relation like in cone we have, this is in cone, this is L, this is R, and this is H in cone. So you know that L square is equal to H square plus R square. So here it is L square is equal to H square plus R minus R whole square. This is the relation between L, R and H. So by using it, we can find any value. Then total surface area. This is the curved surface area. First formula, how to find the volume of a frustum. Second formula, how to find the curved surface area of a frustum of a cone. Third formula, if total surface. You have to find the total surface is, so total surface area of the frustum of a cone, total surface area of a frustum of a cone. Total surface area, obviously it has curved surface plus upper surface, lower surface. So curved surface is, you have already seen pi r plus r l is the curved surface of the frustum of a cone. Then top surface, top is a circle of radius small r, so it will be pi r square. Okay, so this will be pi r square. Then bottom is pi capital R square. So in this way we can write pi r plus r into L plus, we can take common pi r square plus r square. So you can solve some questions, one or two questions on the frustum of a cone.